Hi everyone, in this video we want to talk about graphs and the algebra of functions. Now you remember that a function is just a set of ordered pairs, a special set of ordered pairs where each x is paired with only one y. And usually in algebra we have an algebraic equation that describes the function, but quite often we may have just, instead of the equation that describes a function, we may actually just plot the ordered pairs and describe the function by the graph. So suppose that I have a function f that's described by this set of ordered pairs in red, and then I have another function g that's described by this set of ordered pairs in blue. And if I wanted to find f times g of 6, you'll remember that f times g is just a new function that's formed by the product of the functions f and g. So this would just be f of 6 times g of 6. And remember that f of 6 just means the output, the y value, when the input is 6. So if I come over here at x equals 6, you'll see that the y value for the function f at 6 is exactly 0. So this would be 0. And then g of 6, that's the output, the y value, when the x value is 6 for the function g. So g of 6 looks like that's about 3.5, doesn't it? So if I multiply 0 times 3.5, I'm just going to get 0. Now if I wanted f times g of 9, that would be f of 9 times g of 9. So f of 9, I come over here to the x value of 9. You can see that f of 9 is going to be 1. And you can see that g of 9, right, here's the input is 9, and the output for the function g, the blue function, is going to be 2. So 1 times 2 is 2. If I wanted to find f over g of 3, that would be f of 3. Oops, forgot my of 3 there. So that would be f of 3 over g of 3. So if I look at the x value of 3, I can see that f of 3 is going to be 2. And g of 3, the g is the blue one here, so that's the output, the y value is 1. So that's going to equal 2. If I wanted f over g of 7, that would be f of 7 over g of 7. And you can see that f of 7 is going to be what? Negative 1. Remember, f is the red function, so the output, the y value for the x value 7 is going to be a negative 1. And looks like g of 7 is up here about 4. So that would be negative 1/4. Now notice, if I wanted to find the domain of any of these combinations of them, notice I couldn't talk about like f minus g of 2 because there is no g value at 2, right? And likewise, I couldn't talk about f minus g of 10 because there's no f value at 10. And so what I need to look for is where these functions overlap. You can see that the only x values that are going to have outputs for all of them are going to be between 3 and 9. So the domain of f minus g, the only thing I could plug into that would be values between 3 and 9. Same thing for f times g. The only thing I could plug into f and then plug into g that would work in both of them, right, that would be, again, between 3 and 9. And the only thing that would be different is if I look at g over f, oops, that's supposed to be a division bar there. Okay, so the domain of g over f, well, it's gonna be 3 over 9, 3 to 9, the interval from 3 to 9 again. But remember, I can't have the denominator be 0. And notice when I look at this function f, the output's going to be 0 at 6 and at 8. Okay, so I want to say here, except for x equals 6 and x equals 8. Okay, so x cannot equal 6 or 8. All right, so we might want to just write that in set builder notation, the set of x, such that x is between 3 and 9, and x does not equal 6 or 8. Okay?